we're officially beginning now. I'm just scanning Zoom. So do put it on the grid view if that's something you enjoy. And just go through some top tips tonight. You know, you can leave your camera on as much as you want. If you're in a quiet place, you can stay unmuted. If you've got a bit of background noise, and mute, but you know, we're a very open session here, you know, we're very inclusive. You know, nobody has a monopoly on brain power in the future. You know, it's a democracy here at MKAI, so we'd like everybody to get involved. If you want to put your organization name, you can rename yourself and just put your first name and the organizational business that you're with if you want, or you can keep a surname as well, whatever works for you. You know, do use the chat. We have this amazing extra channel now that we're virtual. So put your thoughts, your suggestions, your questions, your ideas. If you disagree with something, put it in there and we'll try and answer as best we can. I encourage the speakers to look into that as well and certainly see any wonderful affirmations that they're getting, because why not? That's a nice thing to see, but also any questions they want to answer directly in the chat. You can message me privately, but feel free to share your thoughts with the group. And after the speakers finish, we're going to be very, very tight on time. So it'd be great if each speaker can have a look through the questions and just see if anything was left open from their talk. Try and run to about 18 minutes per talk. Gives me a couple of minutes to do the intros as well. Anybody have any particular questions before we launch in tonight? Anybody want to ask anything? And one thing that happens quite a bit is people message the whole group and just send it to me. And so I'll just remind everybody now that you want to make sure you're not clicking on me and sending that, because I love seeing your messages, but the other people miss out. So it's 3 minutes past. We'll start doing the introductions, and I'm going to ask our two wonderful sponsor partners to say who they are as well for a couple of minutes and let you know how you can get in touch with them. And you did just mean to send that to me, sorry. I won't name names, but whoever sent that, thank you. I'm sorry I corrected that. Thanks for the message. Yeah, amazing group, amazing family here tonight, as always. It's absolutely wonderful. 97 of us now from all over the world. See so many familiar faces, so many people that I've been spending time with and learning more about their worlds. Absolute joy to be a part of this community. I think we'll go a little early, so we will ask Amy actually just to kind of spend a couple of minutes telling us about why we might want to come and have a chat with them, if that's okay.
Sure. So
is that you, Rhys?
I'm Rhys,
Yeah,
representing Amy today, and I'm one of the Amy data scientists. We're a technology company based in Milton Keynes, although unfortunately due to COVID, we've spread out across the country back home and haven't seen the office for a few months. We have a whole bunch of expert data consultants, and we help large organizations from water companies to automotive manufacturers looking to derive value and insight from their data and information. We use next-gen AI technologies and ML technologies to do this, including one of our own in-house products, Insight Maker, which helps organizations to discover and manage all sorts of information across their systems. Basically, we use data and AI to help organizations get where they want to go faster and with smarter insights. One thing upcoming that I'd love to bring to your attention quickly is we're working on a new upcoming Data Hack and Innovation Festival. There's one which is happening next month on the 24th of August. We're working with Anglian Water, SES Water, Essex and Suffolk Water, and Welsh Water, and we're looking how to harness data to solve 4 problems related to water consumption and smart metering. Any recruits from data scientists or people with other skills they think they can bring from the water industry and beyond are welcome. So if you fancy joining that session on the 24th of August, you can drop me a line on LinkedIn or email me at rcook@amy.com. I'll post that in chat and remind you about it in my session later. Thanks, Richard.
Thank you, Rhys. Nice and concise, and can't speak highly enough of Amy. Just an incredible company. It's a real privilege to work with you. And I'll just pop that URL up there as well. Addy's like my best friend. I've spent most of this week with Addy. If I'm not on podcasts, I'm on LinkedIn Lives with him, or I'm chatting with him on WhatsApp. So tell us a bit about Data Reply for a couple of minutes.
Absolutely. Hi, everyone. Thank you, Richard. My name is Adi. I'm an innovation consultant at Data Reply. We are part of a bigger group called Reply, an Italian IT consulting group. Basically what we do as Data Reply is we work in all things data and AI. So the podcast that Richard's referring to is where we spoke about ethical AI. That's something that's really exciting for us at Data. So we basically build and design bespoke data solutions, AI solutions, quite to the need of our consumers, and we have customers from across industries, so we're agnostic that way. So basically taking from embryonic ideas to sort of scaling impact is how I'd like to put that. And I think the best part about working at Data Reply is we're predominantly advocates of design thinking and human-centered design. So we look at how the technology that we build impacts humans, and how do we ensure that our design is inclusive, ethical, and scalable. So that's really the kind of work we do at Data Reply. So yeah, any questions, you can always reach out to me. I'm sure Richard will give you.
If you get a chance, Eddie, put the links up to the LinkedIn Live and the podcast that we did,
so
people can.
I'm gonna get that right away. Thank you.
Yeah, check them out later on as well. Thanks, thanks both of you. And I think I'll put up your in just a second. Actually, I've just moved out the clipboard. We are 2 minutes ahead of time, so let's make the most of that and let's jump in. It is another incredible group of speakers tonight. I said a few minutes ago, but some of you weren't on the call, that we have a technical session starting in 5:30. So don't go anywhere for now, just sit tight. And then we're going to open up Reese talking about using ML and how they solved a problem for a major water company around absence caused by COVID. These are people that have to keep these pipes running. So a really interesting project. They're going to share behind the scenes what went on to de-risk that. So that'll be later on. We'll create a breakout room for that. In the meantime, we're going to have our first speaker, who's about to line up and give sharing rights to. That is the incredible Melissa Sassi, who the chief penguin from IBM Hyper Protect Accelerator and the CEO and founder of MentorNations. It is unbelievable that Melissa's come to talk to us from over the seas. And she's going to kick us off tonight. She's going to be sharing the stage with a couple of other speakers that I'll ask her to introduce during the session. She's startup program manager at IBM. She's all about empowering early stage entrepreneurs with technology, business acceleration, cloud credits from IBM. She's division head for Call to Code. That's an initiative aimed at preparing for and responding to disaster scenarios with technical innovation. She's chair of the IEEE Digital Skills Working Group. She's on the steering committee of the Coalition for Digital Intelligence for the World Economic Forum, OECD. I mentioned IEEE, the DQ initiative. She's CEO of MentorNations, a group-led digital skills movement, inspiring the lives of the underserved via access, skills, utilization of technology. She's got 2 master's degrees, supply chain and finance. She's on her way to getting her PhD, focusing on digital inclusion of the unserved communities. Makes me wonder what I've been doing in my life, to be honest, when I read that.
I know, right? Every time I hear somebody go through my bio, I'm like, wow, how did this how did this girl from a small town in Missouri, the center of the U.S., who was never talked to about college? My parents didn't go to college, and I think for many many of my studying years, they thought it was a big boondoggle and a big party, which it was not. Let me tell you. All right, cool. So I'm going to quickly just do an introduction of, kind of me in my words, and then I'm going to tell you a little bit about some of my work, some of our work, And then I am going to bring a couple of my colleagues and friends onto the virtual stage, so we can talk about a few different programs where we partner together. So, you know, as he mentioned, you know, I run a startup program at IBM, and my entire job at IBM is all about empowering youth, empowering the world, empowering early stage entrepreneurs with access to technology. And that's not just saying, let me give you some cloud credits, good luck, go have a good time. It is, how do you empower people with real meaningful skills to make meaningful use of the internet, to make meaningful use of technology in front of you, whether that's learning to code, learning data science, and doing something with it. You know, again, not everybody should be a, you know, engineer. Not everyone should be a data scientist. But I think it's important, especially for young people, to understand what career opportunities are in front of them. And what are, you know, the skills that a data scientist needs, for example. So a lot of the talks that I do, you know, sometimes they're with women and girls or just different people from all over the world of, you know, if you do want to become a data scientist, what does that look like? You know, what are the skills? And we often see a lot of, you know, infographics that flow around Twitter or flow around, you know, LinkedIn about what those skills are. And I find that a lot of those depictions, and they often get a lot of shares, and they don't necessarily take into consideration the importance of problem solving and business acumen and understanding, you know, why are you doing what you're doing, and critical thinking, presentation and storytelling skills. So it's not just about how do you create this amazing data model, this amazing predictive model that's going to, you know, help you with, you know, patient experience, for example, in the health tech space. But how can you really be a problem solver? Because in my mind, a data scientist and an engineer is all about problem solving and critically thinking and creating solutions that are needed in the world, whether that's to solve a big, wicked world problem, you know, something like you would see captured in the UN Sustainable Development Goals, or something else. My outside work outside of IBM is centered around empowering youth. You know, as Richard mentioned, you know, we've got an IoT lab, a robotics lab, and a coding lab in North Africa in Tunisia. And it's all youth-led and youth-run, where we've, as he mentioned, taught tens of thousands of young people about digital skills. So that means I've run countless hackathons. I actually have the career I have today because I participated in a Microsoft employee hackathon. And I identified a challenge at Microsoft when I was there. And I pulled a team together that ended up growing to be, you know, 50, 60 people from around the world. And we were looking at how do we put devices into the hands of underserved communities so that Microsoft could truly live its mission of empowering every person in every organization on the planet to achieve more. Without access to a device, without access to the internet, and without access to the skills, how can you make meaningful use of the technology in front of you? I ended up winning first place in the Inspired Me category out of 4,000 teams worldwide. I ended up being able to pitch to Satya Nadella. So I'll put my Twitter handle in here, but it's my background photo is me pitching to Satya, which is, and he's listening, you know, and I didn't get fired. It was great. We ended up rolling out my idea, you know, worldwide, and that program is now in place and managed by Microsoft's philanthropy team. And so I feel very proud, you know, when I look at, you know, the power that even participating in a hackathon and what that can do to create a new opportunity for, you know, a young person or even a seasoned professional. For me, it gave me a new career path, and it made me realize that I want to incorporate this concept of doing well while doing good into my job and into my life. I ended up landing on a really wonderful opportunity at IBM, decided to leave Microsoft And now I run many, many different coding camps and hackathons. One of the flagship hackathons that I ran, and this was all about COVID-19 response, was partnering together with UNESCO in a program called CodeTheCurve. We also partnered with SAP, had about 10 different collaborators from Internet Society to a organization that has 30,000 CEOs in 130 different countries. It's called YPO, and a whole lot of other really amazing organizations where in 9 days we had 200 applications to join our hackathon. We selected 40 teams. We did a week of online learning, and it was all about data science skills. We laddered up into three themes. And again, it was all about fighting back against COVID-19. It was data sharing and information management, education or distance learning, access to education during COVID-19 and beyond, and then health and social issues. All teams had to have at least one male and one female to make sure that the teams were thinking about gender inclusivity. All teams had to have at least one person under the age of 25. And so this also encouraged youth engagement. So we were thinking about, how could different people from all over the earth, take part in this. And we selected 40 teams. Those 40 teams, I think 34, 35 ended up completing the entire hackathon, which included 20 hours of online learning. Of the 20 hours of online learning, again, it was data science, pitching, professional development, storytelling, ethics in AI, media literacy, media disinformation and misinformation, other types of hardcore tech skills. We brought in more than 100 mentors to help them through this online hackathon, and we did 3 days of hacking. We did pitch practice, and at the end, 167 people participated in the hackathon from 25, 26 different countries. And we selected 3 winners. And I'm very excited that I have 2 of those winners with me today. What I'm also excited about is that one of those winners also went on to participate in another IBM hackathon. Fun fact, the other hackathon, Call for Code, Lady Gaga actually tweeted about this project. So we were kind of cool, for a bit on Twitter, seeing Lady Gaga talk about our project. Chelsea Clinton is the one who announced the winners. So with that, do we have Ali? Ali, are you with us?
Yes, I am.
Ah, there he is. Awesome. So Ali, I want, and I see we have Joaquin. Good. Ali, I know we've been on many of these together, and obviously we've been working closely together for quite a few months now. Can you take a few minutes and talk about, what did you get out of the, why did you decide to participate in the hackathon?
Mm-hmm.
What problem were you trying to solve? I know you've got an amazing pitch deck, so I'll let you do your pitch, but I want to also hear just, what did you get out of it and what's next? But the floor is yours, Ali.
Thank you, Melissa. I guess what I got out of it was part of what I really went into tech in the first place for. And one of the things that I feel the majority of the people that are going to talk today or that are even participating, like one of their biggest motivations for getting into tech. And I think that motivation is really to impact people. There's this famous saying that many of us have heard about from Arthur C. Clarke, where he says that any suitably advanced technology is indistinguishable from magic. And I'm paraphrasing here. Interestingly enough, it goes deeper. The Proto-Indo-European word mag, like where the word magic originated from, it actually means to help and to enable. And really what AI is doing, what machine learning is doing, what tech is doing, what we're all working on is helping each other and enabling each other. My personal journey in tech started off helping people. So currently I'm working on a fintech startup called Fostrum, but the way all of our co-founders initially met was we were in university. We noticed there was a problem with the homeless in a place called the Downtown East Side, which has a huge homeless problem. And many of them weren't able to get essential skills, like they weren't able to go to essential services. They weren't able to go to detox clinics. They weren't able to get services from various nonprofits because they didn't have a physical piece of ID. So we worked on creating a virtual ID for them, and we loved working on it so much, we said, hey, let's work on a startup together. And fast forward, one of the things that we've really integrated into our startup, Fostrum, is having a very customer-centric focus. So what our startup does is it's a control center for solopreneurs that manages all the number side of things and takes away the number anxiety a lot of people face. What we've instituted is pretty much every week we talk to 2 or 3 customers about what their biggest pains are. And when COVID-19 was just starting out, we kept on hearing things over and over again from restaurant owners to e-commerce stores across many verticals that people wanted information. They would tell us that I spent hours every single day looking at the news. When is the prime minister going to talk about a grant program that's relevant to me? Like what are the cases? When are things going to change? How am I going to pay my rent? There's over 60 federal programs that are announced related to COVID-19, even more that are provincial or privately run. Which am I eligible for? How is this going to affect me? And when I first heard about the CodeTheCurve hackathon, I thought, wow, this is we're not first line responders. We don't have any skills when it comes to medically helping these people impacted, but we have magic, we have tech, right? So we can change their lives. And my entire team got together and we were like, hey, let's join this hackathon. And over those 3 days, we put together a prototype, which consisted of a curated list of programs and grants to help businesses really get the support they need. And we focused on small, medium-sized businesses because they make up 99% of the economy here. And really, things aren't going to go back to normal when social distancing ends. And I think a lot of us are seeing that now. They're most likely going to go back to normal when the economy starts healing, when jobs start coming back. So right from the beginning, we recognized that, and that was our focus. We also created a prescriptive simulation tool that assesses and forecasts how a business might be affected across various different pandemic scenarios with industry and location specific personalized recommendations. And while we were working on it, we messaged various universities and we got a local professor reaching out to us about creating a heat map.
Oh, and
so
hey, Ali, we got 1 minute because I think I talk too much.
No, not at all. I'm almost.
I told you I was going to be like the time time checker, which thankfully Richard is the time checker for me, and so everything just rolls downhill.
Yeah. No, thank you for jumping in there. I wasn't checking my messages, but yeah.
No worries. I didn't message you. I just figured I'd jump in and let you know. So keep going. Cool. It's
Appreciate
awesome.
It.
But let's give you 1 minute.
Awesome. So yeah, we put together a heat map that showed which industries were particularly impacted by COVID-19, because we realized that in past economic hardships, a lot of the times local governments, they overpromised and underdelivered. So we wanted to really visually illustrate which industries were impacted in which ways and which industries weren't getting the aid or the grants or the funding support that they needed. And yeah, since then, we've been making it into a fully scaled solution. We've gotten immense support from Melissa, from IBM, from SAP, and we're scaling it worldwide. And we've added new things to it, like COVIDians, which is kind of like Humans of New York, but really hearing the personalized human stories of these SME business owners and how they've adapted and how they've been resilient through the pandemic. And yeah, that's pretty much about what we've been working on.
Awesome. I was really excited to see them land both CodeTheCurve and Call for Code, and incorporating IBM technology, solving a big wicked problem, utilizing AI in a meaningful way, and again thinking about how do you solve big wicked problems that real people have and again, incorporating technology in a way that facilitates that. So thank you, Ali and Joaquin. Let's have you come in and talk about, what you've created and your CodeTheCurve magic.
Yeah, thank you, Melissa. Well, I think that this is a great opportunity. So in my case, I'm working in a group on medical imaging in Madrid and a university. And our main motivation to participate in such a really interesting hackathon, it was basically to learn from practice. So I had a group of students, and when the pandemic really hit Spain really hard at the beginning, so in March, we even lost some relatives during that period. So we were like, we need to do something, and based on our skills working on medical imaging, artificial intelligence, we started just to think about like, okay, how can we help? I think that this is a common situation for many people all around the globe. So just in our case, we started just to talk with radiologists, physicians in different hospitals, and at that point they were really overwhelmed with the number of cases, the number of images that they were acquiring. And in the case, for instance, in Spain, the most common tool that it was used for deciding on patients about if they had to get into the hospital, if they need to change the treatment is, well, and it is still chest X-ray. So in other countries has been different, but in some countries such as Spain, Italy, and they have been using massively chest X-ray. So the number of cases that they had all around the world, I think that the estimation is that more than 100,000 chest X-rays of people with suspicious of having COVID-19 has been examined. So we started just to work on how to apply AI, not just for the diagnosis, because we know that there are other tools, but also to analysis on the progression of the patient. This is something that talking with physicians, this is what they really wanted. So I think that this is one of the best lessons that we got from the beginning, talking with the people who are gonna be actually using these kind of tools and get what they really want or what they really need, not to offer something that is not useful for them. So just working on this, so it's in our case, working more on a dynamic images, so it's not just something static as the single image, but having this acquisition over the time to predict the prognosis, how it is gonna evolve the patient, and working on really developing all these tools using a web page, because we really wanted to have this technology so that many different countries, not just in Spain, we had been working and talking with people in India, radiologists in Costa Rica, in the US, in France. So we have been talking with many different countries and trying to have something that is useful for everybody. I think that this is a really global problem that requires global solutions. And we have been working and receiving really helpful advice, support, as Melissa from IBM, also with companies such as Google, Amazon, who has been supporting these projects. There is a lot of computing needed to actually analyze all these cases, the number of cases that we got from Spain, the other countries that are also providing data, and then trying to actually have something that is really meaningful for many different cases. So I think it's clear for those who are working on AI that trying to create something that it can be used outside of your initial data set is challenging. I know that it's easy to train something that works in a particular field, but when you want to deploy and to have something that is applicable for many different other data sets, this is more challenging, and this is what we are working on right now. And I think that has been a really exciting time. I think that it's clear that now what has happened these last few months has really demonstrated the importance of AI, the importance in this case of telemedicine, how these kind of tools that has been around for a while, now it has the perfect timing just to demonstrate its utility. So I think that has been a really exciting experience, and now we are ready just to go on and actually to continue deploying this in more different centers.
Awesome, awesome. Thank you. So you had an opportunity to hear from, two of our winning participants. You might want to know, and I'll quickly wrap up because I know we've got an agenda to stick to today, and I'm not always good at following the rules. But if you think about, for me, when you're engaging in any kind of startup competition or coding camp or hackathon or anything like that, how do you make sure it's not a point in time? And, as part of, empowering these two winners and the other one who won the CodeTheCurve hackathon, they get 1 year of business and tactical mentorship, access to systems, and opportunities to pitch at IBM events, as well as SAP events. And so many of the things that we try to do is how can we help them to take those ideas forward? For any of you who are thinking about how do you empower and share your skills forward, don't just think about things as a point in time. What can you do to, create self-sustaining solutions, or solutions that won't just be a point in time. That's often a big failure of many hackathons and coding camps. So with that, I want to thank you for taking the time to listen to us today. And whatever your journeys are, and wherever your journeys might take you, stand up, do the thing, whatever that thing is. We're all, experiencing new life and figuring out what this new life is. But, continue to show up, continue to learn, and continue to do that thing, whatever it is. Thank you.
Thank you, Melissa. Thank you so much. Thank you, Ali. Thank you, Joaquin. That's wonderful to hear these real life examples. Thank you. Thank you for sharing those with us. Okay, this is where the choice comes up. I'm going to create a breakout room now. So I'll remind you of your two options now. We've got about an hour. Going to start in the technical break room. Herraiz Cook, give us a wave, Herraiz. There he is. He's going to talk about how they de-risked a problem for a major utility company using machine learning. And you're very, very welcome to stay in that session. Over here, we're going to be moving on with the keynote speeches on the main stage with Professor Christoph Lütger, Director of the TUM Institute for Ethics and Artificial Intelligence at the Technical University of Munich. And then I will endeavor to give a nudge to the breakout room as we start with Dr. Richard Benjamin's Chief AI and Data Strategist at Telefonica at 5:50. So hopefully you think that's a pretty tough choice. I know I do, but all sessions are recorded, so you will absolutely be able to catch up in the future either way. I think you all know the website, mkai.org. We already even have the page up for the archives, but it's just pending the videos, of course, which will be live tomorrow. So do head over there, and there's details of our next event over there as well, which actually I will just put that up now so everybody's got that. So that's August event in the chat. So don't be shy, go and register in the background if you want on this session or as soon as it's done, and make sure we see you next month. Right, let's test the technology, which is always fun. So I'm going to send everybody over to another room, and if you want to come back into this one and hear Christoph and Richard, then come back in and join us, and we'll reconvene in about 30 seconds.
As I'm new here, Richard, can I ask, typically, if you've run these before, what's the split between, or is there a pattern in the split?
It was 50% each actually last time, about 60 and 60 last time, but it's always a bit of a moment, to be honest. That's like, just see what happens next. We have 35 in this room, and therefore we have the balance. I think it was about 115, 118 people when we did the split. And yeah, we'll this number will just rise, so we'll just give it a second.
We should team up with that Milton Keynes escape room company and make people stay in the breakout until they've solved the problem.
Brilliant, love it, yes.
Brilliant, Alex. Okay, we will make a start, and people are very welcome to skip back and forth between the rooms, of course, as well. So what a privilege. Hopefully Christophe is in the, yes, there you are. I love your background, by the way, Christophe.
Yeah, thank you very much for the introduction. Let me share my screen now.
Yeah, let me give you options. And just while you do that, let me just tell you who Christophe is. He's Professor of Business Ethics and Director of the Institute for Ethics and Artificial Intelligence at the TUM in Munich. Background in business, informatics, and philosophy with a PhD. He was awarded the Heisenberg Fellowship in 2007. Congratulations. Numerous books, including The Ethics of Competition, visiting positions at Harvard, University of Pittsburgh, University of California, Taipei, Kyoto, Venice. He's a member of the scientific board of the European AI Ethics Institute, AI for People, as well as the German Ethics Commission on Automated and Connected Driving, a topic I love, and consulted with the Singapore Economic Development Board and the Canadian Transport Commission. You like to keep busy then, Christophe. That's my reaction to a CV like that.
I'm trying. Thank you very much for this very kind introduction. So as you see, I take a look at the issue of AI ethics from an academic angle, and I will give an overview of some of the initiatives of our institute here at Technical University of Munich, as well as some of the initiatives and projects that we are running over here. So hopefully you can now see my presentation. So this is we are here at the Technical University of Munich, and the Institute for Ethics in AI is an institute of this university where I am professor. And let me just give you some aspects of what we do, what events we're running, and some of our research highlights, as well as what's upcoming. So what we are doing is, of course, as a research institute, we are carrying out and supporting research. But we also see ourselves as a platform for cooperation between many different stakeholders, from not just academia, but from industry, as well as civil society and also politics. And we see ourselves as a resource for these stakeholders, for information, but also for cooperation on ethics of AI and responsible AI. So our institute is fairly new. So it was just opened in 2019, actually in October 2019, which this was our picture from the opening with the German Minister for Digital Affairs, Federal Minister of Digital Affairs in the middle, and our president of the university to the left. Since then, we have been very active in running several events as our speaker series with professors from AI and AI ethics from the US, for example, Carnegie Mellon, as well as just today we had Hugh Price from Cambridge, from the Leverhulme Center for Ethics, for Future of Intelligence and Ethics here. We have been cooperating with institutions in the US, for example, in the Future Forum in New York last November, as well as a number of others. We hold regular workshops, for example, on European guidelines on data ethics and AI ethics, such as one with Paul Nemitz from the European Commission in Brussels, as well as a number of others. Yeah, I won't go into all the details we are doing, but just jump to our networks and initiatives. So who are we partnering with at the moment? So one of our major partners is Facebook. We received a major grant or research gift, actually with no obligations attached from Facebook last year, actually $7.5 million for carrying out research, independent research in the field of AI and ethics. But we are not focusing exclusively on Facebook. We have projects with the German government here, the Bundesministerium für Bildung und Forschung, a federal ministry, with the Bavarian Free State, as well as the IEEE, and a number of others, and our unicorn from Munich, Celonis, which is a company in this field of data mining is in particular, and others. And one of our very new initiatives we have just started is the Global AI Ethics Consortium with these members that are listed here. Just after a few weeks after COVID started, we launched this initiative to work on responsible AI, now mostly in the context of the fight against COVID and other pandemics maybe. And in the future, but we are definitely planning to enlarge the scope of this consortium. And we are partnering here with institutes from universities such as NYU, from Cambridge, Oxford, the Sorbonne, but also the University of Tokyo or the Beijing Academy of AI. So this is a very new initiative, and we have just selected some projects that will work to so it's not just a platform, not just planning to do something, but we're actually carrying out research here in these fields. We are also running and have launched the Responsible AI Network for Africa, where we are partnering with several universities, in particular in Ghana, as well as Uganda and others, in order to promote responsible AI in research across the continent. And here again, we are also partnering with other stakeholders from industry as well as civil society. We have run a number of virtual workshops with huge interest here from the area, as well as from all over the world, I should say. And we are just getting started here, so to speak. Now our research, what are we doing in terms of research? So these are our current 7 clusters of research in which we have actually projects, and these range from AI in the future of work, AI mobility and safety. There you find your autonomous driving, which was mentioned earlier on, which is which is huge interest here in Germany, of course, with its car makers and many companies here working in this field. As well as AI in medicine and healthcare, online behavior, AI and sustainability also, which is becoming a major issue, as you all know. And for example, in the field of AI and sustainability, we just started a project that is about AI in Earth observation, and we are the partner that works on the ethical aspects of this, which includes, for example, data protection, which includes fairness and avoidance of biases and similar issues. What is peculiar about our institute is that we are not just the typical research institute that is working within one discipline and with a stereotypical and standardized type of researcher, but we are doing research actually with, at the moment, already 8 different schools at our university. And in all of our research projects, we have one PI from the technical side and one PI from the social sciences or humanities or law. And they are working together mostly in PhD projects, postdoc projects, and similar ones on these topics. So as you see, Technical University of Munich is yeah, one could say certainly that one of the top technical universities in Germany, if not the one. And not just in Germany, but also at least across Europe, it's certainly one of the top ones. So here are just some titles of our current research projects. I'd already mentioned the AI for Earth observation, where we have something about autonomous driving ethics, preference-aware optimization systems, which is, for example, run, as you see here, together with the people from mechanical engineering, as well as the School of Governance. We are working on medical ethical advisor systems for ethical decisions of doctors, for example, in collaboration with the computer engineering school, as well as the School of Medicine. I won't mention all of these, but here you see more about, for example, AI-based interventions against online norm violations, online firestorms, and about their dynamics, predictability, and mitigation, as well as about trust in machine learning. We also, if you look at our website, we regularly publish research briefs. For example, the most recent one to the left was about ethics and the use of AI-based tracing tools to manage COVID. We took a look and compared, but not just compared, but also took a look at the ethical implications of a number of Corona apps basically around the world, and what their implications are, what their problems and their chances and limitations are basically. This is some of it has already been mentioned. We work on AI and human rights. I just published for one of my staff members an article here. The AI for people has been mentioned, as well as others. And just at the end, I would just talk about upcoming events. The one on the bottom has just been today, actually, so it's not upcoming anymore. But we do these responsible AI Africa workshops in the future as well. We held one this week on responsible AI in agriculture, which was a great success. And our major event next year will be the Responsible AI Forum in Munich, which was planned for this November, but postponed to next June, in which it will be held in Munich from 7th to 9th June next year. And we have calls for papers and also calls for workshops and a number of other formats running here. This is also not just the usual academic conference, but is planned as a conference for partly academic, but also one for industry, civil society, and others. We will have a short preview, digital preview on this conference in this November, actually, which will also be online soon. So thank you very much, and feel free, of course, to follow us on social media as well as elsewhere. Thank you very much.
Christoph, thank you so much for the update. Let's just have 30 seconds or so on this question that's come up. It's all about the speed, wasn't it? And question from Alex: are you seeing organizations driven by client requirements? Just jumped off my screen. Regulatory, legal concerns, or ethical principles? Client requirements, regulatory, legal concerns, or ethical principles? What are you seeing there?
I mean, they are driven by a lot of things. Of course, they are driven by making profits. This is important. But my point, as you mentioned, I'm a professor of business ethics originally. I would say there is no necessary conflict in all the time between business requirements and ethical requirements, as I like to stress. And that's why with AI ethics is the same. You may risk your reputation, you may run into scandals which damage your brand value, and you might also, as we have seen in many cases now, be faced with having to pay heavy fines. And so this is something we would like to avoid, and that's basically the reason to do ethics and AI ethics as well, as a number of companies are starting to recognize.
Thank you so much. Hopefully you can stick around. Peter, go on. I'll do your question very quickly then. Who do you view as the primary beneficiary of your research, and how do you assess your effectiveness? But shorter the better, if that's okay.
Yes, actually, I have a look at the world and see if it's got better. But we also actually have tools for companies, like an integrity index that we have developed, which is also being used actually by a number of large companies now in Germany, in order to assess where are you making progress in terms of ethics and integrity. So we have tools to do that, and I would see as beneficiaries companies, but not just companies, but of course also users and the general public, other stakeholders such as NGOs. So I hopefully, if it works out, this will be a win-win for all.
Christoph, thanks again. Hopefully you can stick around and do a bit more Q&A at what would be about 6:40 for us our time. Thank you so much. Please join me in thanking Christoph on the chat for his update, and I'm sure he'd welcome you to follow him on Twitter and LinkedIn as well to stay connected with his work. Brings me straight on, and I have alerted the breakout room that we're switching. So Richard, I'm sure a few people will be jumping over as well to catch your talk. So this is Dr. Richard Benjamins, Chief AI Data Strategist from Telefonica. What a privilege, Richard, to have you join us tonight. He is rated, I'm going to embarrass you here, Richard, sorry, but he's rated amongst the 100 most influential people in data-driven businesses. He's a co-author and vice president of the Spanish Observatory for Ethical and Social Impacts of AI. He was group chief data officer for AXA, and before that worked 10 years at Telefonica on big data analytics. He's the founder of Telefonica's Big Data for Social Good department, a member of the B2G data sharing expert group of the EC, frequent speaker at AI events, and has a PhD in cognitive science, published over 100 scientific articles. So hopefully we think we're in very good company with Richard tonight. Thank you for coming to talk to us. The time is yours.
Yeah, thank you very much, Richard. Can you see my screen? Yeah, okay. So I'm going to tell you a bit about what we did in the community and in Telefonica of using AI and big data for social good, in this specific case for fighting COVID, the COVID crisis. I will give you a brief overview of what we talk about. First, I'm going to explain you what kind of data is used to work with this kind of projects. Secondly, I give you many examples of what actually has been done in reality for COVID. And then this is all work done with governments. So I want to highlight a little bit on how that is. Yeah? And as you will see later, it's not so simple to work with the different types of governments if you want to solve a crisis on the spot. And finally, what should we do? What are the challenges and how can we move forward to improve better on the next pandemics? So let's first look at something about big data. Yeah? Anonymized and aggregated big data can be seen as a proxy for human activity. Yeah? It's a bit like Plato's cave, where the people, in the cave saw some kind of shadows, and they interpret many things from those shadows, even though they didn't see the reality. But actually the shadows were a proxy of reality. And that's the case with big data as well. Yeah? Here's some examples. If you look at, for instance, payment data coming from financial institutions, if you anonymize, you aggregate that, you can get fairly good estimations of the consumer price index, poverty rates, and even the economic impact of natural disasters. Yeah? We've seen it also today with COVID. Many economies are in danger, and during the confinement, this is perfectly reflected in the data that the financial service institution has. You probably all remember the work with that search engines like Google did with the influenza breakouts. People who have symptoms start to look at, and if you follow where those search queries are made, you actually can get an idea how this propagates. Yeah. Later on, there were found some problems with this approach, but anyway, yeah. So it's an important proxy, and I said it's a proxy. Yeah, it's not perfect. It can be wrong. Satellite imaging can be used to measure the increment of GDPs rather than looking at statistical offices. And that's of today, mobile phone data can be used, for instance, to estimate literacy maps and also socioeconomic levels by simply looking at how people top up or pay their bills. Yeah. Let's look at those proxies in one country, Spain. This is Telefonica's mobile network. It's about 150,000 antennas, 1 billion events a day, over 20 million customers, and almost 1 million roamers a day. Of course, this is pre-confinement. It will look very different now in terms of travelers. And so this is anonymized and aggregated, a proxy of, as we will see, mobility. Yeah? And we all know that COVID is a contagious disease, and therefore the factor of people moving around is very important. Yeah? This has been recognized, even though a bit late, by many governments. So the European Commission started end of March to ask the operators in Europe to share some anonymized and aggregated data to fight COVID. It was end of March. The crisis started at the beginning of March, so it took them a month to act on that. And only recently, a few weeks ago, or actually maybe last week, they published the first results in 3 reports and a press release about their analysis of Europe. Yeah, if you're interested, it's really interesting to read. We will see some examples here, but not only those, not only the Commission, also basically every European company, many African countries, many South American companies, Asian companies worked on this to use this kind of telco data, anonymized and aggregated, to understand better the development of the crisis. Yeah. Now let's see a few examples. Yeah. If you look at how this data helps, there are basically 4 basic use cases. Yeah. First, mobility patterns are very stable across the country. Yeah. They don't change a lot. So if you understand those mobility patterns and the crisis and the virus enters somewhere in the country, you can basically predict where it will propagate first. Yeah? And that can help you to prepare hospitals or to confine certain areas. Yeah? Of course, if you do this after 1 month when the virus already propagated, then it doesn't have a lot of effect. Yeah? But it's important to do this upfront. Once you have the crisis there, you need to confine. You as a government want to know how this confinement is followed up by population. Yeah? And therefore you can monitor this at the province level, at the region level, even at the city level, and sometimes at the district level, just to understand if things are going well, and if not, then maybe you can take actions. Yeah? The third one is to improve the epidemiological models. Yeah? So those are mathematical models that predict how a virus propagates. And of course, these are viruses that are contagious, that there is a mobility factor in the model. But traditionally, those mobility factors are coming from census data, yeah? Static data, whereas if you are in a crisis, mobility data is very different. So if you put in weekly or even daily data, you can actually refresh the predictions on a frequently basis, and that can help you find out where the crisis will propagate, and that can help to find additional, to supply additional medical healthcare or prepare intensive unit cares, etc. Yeah. And finally, it's about economic recovery, because we all know that it has been very hard for many economies by closing down the whole countries, and it is important to also measure and monitor this recovery of economic activity. Yeah? And as you may understand, mobility data, so how people move around, is very much related to economic activity. Yeah? The more mobility, the more activity there is. Now let's see a few examples across different countries. Yeah? This is the mobility in Spain. What you see at the bottom are the days and the bars that you see. So the first bar is actually video, are just before the confinement in Spain, where mobility is in the 90s. Then there is some announcement, it goes down, and then there is the confinement, and you see sometimes it goes down all the way to maybe 80 or 90%. Yeah, and you see this at the province level, but you can also see it at city level and at sometimes even at district level. Yeah, so this gives the government an insight, and actually this is publicly available. Yeah? The government an insight as to how confinement measures are fulfilled. You can definitely see the patterns of the weekdays and of the weekend, even public holidays, etc. Yeah? Here's an example of Brazil. In Brazil, the relation was not directly with the government, with an industry organization of telecommunications companies. They came together and they worked together for 2 specific use cases. Again, this was monitoring of isolation of population, and also detection of accumulation of people in strategic places, in terms of for strategic places for fighting the crisis, such as hospitals and test locations. Now, you've all heard the news. You see what the news of Brazil. So it was very hard to do this at the federal government level. So this has happened at the state level. Yeah. So 17 states have joined, and 20 municipalities across the country. Yeah. Argentina. In Argentina, use the same type of data to calculate a mobility index, which there they considered very close to the R index, so how the R index changes with mobility, and also a transit index, that is people moving inside and outside regions, and comparing that with the pre-confinement and the post-confinement. Yeah? Here they delivered dashboards to government, national, and also to regional agencies for specific use cases like understanding whether the relaxation of the, let's say, confinement was followed, because it always goes in phases, yeah? And you can follow up whether that is correctly happening. Also to forecast contagions, yeah? After the relaxation of the confinement, and also supporting the economic activity. In Ecuador, this was worked with the National Operations and Emergency Center and the government itself. And here also there was actually a prediction of how COVID will predict in the country, because as you all know, in South America, it happened all later. So there was a bit more time for governments to be prepared, yeah, for the ones who wanted to do that. Yeah. This is an example of France, of the work that the European Commission is doing with the telcos in Europe. If you see, so this is a correlation between mobility and cases and infected people, but it uses here a proxy of the number of deaths in excess of past year in certain areas. Yeah? So they use that as a proxy to say, okay, all the excess of that might be caused by COVID. And then if you look at it, these are heat maps, and there is a very close correspondence between connectivity of certain areas. So what connectivity, the rate of connectivity in terms of travels between certain regions of provinces, and the number of deaths in excess. Yeah, and they calculated that it's about 90% you can explain, 90% of the cases you can explain by mobility if there is no additional measure like confinement or masks, etc. Here is the last example. This is also an example of Spain, but this is mostly focused on economic activity. Yeah? What you see here is the map of Spain, with the black lines are the provinces, so administrative levels, but the colors, they group together what is called mobility functional areas. Yeah? So those are areas that go cross-border. They might be within a province. And the lesson here is that those are natural areas of mobility of people, which probably hints at economic groups, yeah? Economic activity. So if you need to release, yeah? If you need to relax confinement, or you need to reconfine, and if you want to harm the economy as less as possible, it is better to use those functional areas than the administrative areas. Yeah? Because if you confine, but you don't split a functional area, then you keep economic activity much more than if you just cut it in two and maybe you kill it. Yeah. So this is a new insight coming from the data that the European Commission wants to translate, yeah, and explain to the different member states to see whether this is an idea either for now or for the future. Yeah? Of course, it's harder for a government to explain mobility functional areas than administrative areas. It's very easy to understand for the population. People in this province cannot leave, and in that they can move around. But if it's a kind of vague border, yeah, from certain areas within a province or a city and others not, then you have to do some explanation. But still, it's an interesting experience. Now, working with governments. Yeah? If you look at disaster management in general, and this is a figure that we use, people who are working in AI and big data for good all the time. Yeah. So by disaster, you have four main phases, yeah, divided in two before the event and two after the event. If the disaster happens, you have an immediate response. Yeah, everything needs to go quick. You need to be in place. You need to understand what's happening, etc. Once you've done that, you need to recover. Yeah? And then you do mitigation, prevention, so it won't happen again. But then you also need to prepare for a disaster. Now, if you look at the situation of COVID, then almost all governments in the world started at response. So once the disaster happened, when the pandemic was really called by the World Health Organization, somewhere mid-March, then they started to think about. They could have started already in December with the first notices, but it didn't happen. There were only 2 countries in the world who were prepared and who acted very rapidly. I'm talking only about big data and COVID, not about other things. And those were China and South Korea. We all know why. They have different perspectives on privacy. So they already had the data in place. They had the data already. And they had already access to the data. So they could act much quicker. And sometimes not even with aggregated and anonymized data, but even with the personal level. So out of the question for our society here at the moment. And if you look at the recovery phase we are now in, you've probably all heard about this privacy preserving proximity tracing, decentralized or centralized, that uses Bluetooth in devices that can help you find out whether you've been in touch or close by a person who was positive. I think only in Germany, maybe a few countries, other countries that is in place, many not. We don't know how it works yet, but definitely something about recovery. But it is worrying that governments across the world were too late. I'm from the group community of AI for Good. We've insisted many times with governments to be prepared, but nobody was really interested. I hope that will change now. Now, if you are a company, you have interesting data for such kinds of things, not only for COVID, but for doing good, the Sustainable Development Goals. There are many ways to work with governments. We've worked with national governments, regional or local governments, European Commission, as you saw. We also work with the National Institute for Health, with National Statistics Institute, with humanitarian organizations, research organizations, and universities, even with industry bodies. So really, it's not really clear how to move forward, how to do it. In the current state of place, it depends more on the people you meet than on the type of government you are talking to. So it's still a kind of mess. This data sharing for COVID is actually an instance of a larger phenomenon called business to government data sharing, and the European Commission has installed an expert group to find out and to help advise on how does this need to happen, because it happens, but it happens only a little, and so it needs to scale and it needs to be sustainable. I was part of that expert group, and I will share with you a few high-level insights. First, the type of data there is. So as you can see, there is raw data, pre-processed data, processed data, and data-driven insights. What we've seen now in this talk is only insights. We've never shared low-level data. It's always the insights, mobility data, origin and destination matrices. At the top, you can see the value chain. It's a typical value rank for data collection and big data, but what's very important is that there needs to be decisions taken with the data. It's of no use if you share data with the government, but then they don't know how to act on it. And that also is still happening. Very quickly, sharing data with governments is a process where you have to take into account many different things. For instance, you have to find out, is it worthwhile? What are the benefits? What are the risks? What are actually the risks of not doing it, not using data, etc. I have to take all sides of other things in account as well. And then there is the business model. How does it work? Is it pro bono? Do you charge for it, etc. What we've seen, and this is about the challenges moving forward, is that the main challenges in this work so far has been first a privacy confusion. So many press and many, let's say, public opinion doesn't distinguish well between personal data and anonymized and aggregated data. And the things that I showed you, which is aggregated and anonymized data, are sometimes mixed up with contact tracing, which has nothing to do with it. Then there is an ethical question. People ask themselves, is it ethical from a privacy perspective to use all this kind of data, even if it's anonymized and aggregated? But I always say there is also the other question, is it ethical not using this kind of data, if you, as a government, you can have it and actually solve the problem quicker and avoid that. Yeah? Then another challenge is financial sustainability. Everything you've seen here is pro bono. It's because companies feel responsible and want to help. Yeah? But if this crisis lasts for 3 years, then few companies will be able to keep it up. Yeah? Because this is all pro bono. But it needs investment, etc. Yeah? And finally, a challenge that I learned is that if a government uses your data as a company to take decisions, and sometimes they're hard decisions, then you as a company and governments need to be transparent on this. Yeah. Then sometimes you as a company may be caught up in a controversial political decisions, and that's the last thing you want. Yeah. So these are the challenges need to be worked on. And actually, luckily, there are several organizations who are working on it, which you can see here on the right. And I wanted just to finish with this. Yeah. So you all remember the tsunami in 2004 that killed over 300,000 people. Yeah? 10 years later, there was this press notice that said, now we have a tsunami alert system in place. Yeah, it works. If there's a tsunami, everybody who needs to be alerted gets alerted. I'm sure it was not pro bono. It has cost a lot of money, but it's there. I think we need something similar for mobile, big data analytics across the world, every country, one operator, relation with the government. If there is a pandemic, within 24 hours, governments have data to stop the pandemic before it is too late. Thank you very much.
Richard, thank you so much. Very, very interesting. I'm burning with questions, but we'll hold those back. If you can stick around for another 20 minutes, then we can take some Q&A, particularly around your talk. Would that be okay?
Yeah, that's fine.
Wonderful, thank you. Well, I'm very pleased to be announcing our fourth and final speaker of the evening. We've got quite a mix of people working on different things. And that's going to be Sharanda Mohanty, co-founder of AI Crowd. He's a CEO there as well, and it's an open source platform for organizing machine learning challenges on a variety of real world problems. Now, he worked on his PhD, and he was working on things like AI from image-based detection of plant diseases to teaching simulated musculoskeletal models how to walk using reinforced learning. He's taken a leave of absence to start and focus on AI Crowd. So he's clearly not scared of jumping into some big challenges. He was a theoretical physicist at CERN on the Public Computing Challenge, an experimental effort to crowdsource the compute requirements of physicists at CERN by allowing citizens all over the world to donate their unused computing power. So Mohanty, if you can give me a wave, unmute yourself.
All right, can you guys hear me, right?
Yeah, crowdsourcing AI to solve real world problems. Stage is yours, welcome.
All right, thank you so much. Although I would correct, I was never a theoretical physicist. I was in the theoretical physics department. I was still doing a lot of machine
No, I read it wrong, I'm sorry, but I just kept going. That's my mistake.
That's fine. I will get started. Just a second, let me check if you can see my screen right. Can you guys see my screen?
Yeah, we're good, yeah.
All right. I'll try and see, just give me a quick second so I can see some faces here, should be fine. Okay, start. All right, I will get started. My name is Mohanty, and in this talk, I'll be talking about AI Crowd, which is actually a side project that I started while I was doing my PhD at EPFL in Switzerland. Then at the end of my third year of my PhD, I had the bright idea to quit my PhD and actually pursue this side project passionately. And that was not actually because I was shying away from my research in PhD, which I actually continue to do through my the new entity AI Crowd, where I think our research output has increased. So I guess it worked out all in the end, and hopefully I go back and submit my thesis. But to get started, I think to give you some context, all of us know it's 2020 and AI is hot. Everyone wants to do AI. No one knows how to do AI. Not no one, well, many people do not know how to do AI. And that's kind of one kind of key problem that we are trying to address by bringing AI Crowd into the picture. And AI Crowd is a community of AI researchers and enthusiasts who are passionate about AI or are learning about AI and are really passionate about solving many real world problems using AI. Now, this was a very interesting report from Tencent. This was from 2017, but I guess the statistics haven't changed much. But the report said there are, at that point, there were about 300,000 AI engineers worldwide, but millions were needed all around the world. And of these 300,000 AI researchers and engineers, many were already kind of absorbed by our classic Google, Facebook, and whatnot, or many of these in in fancy elite research labs. I was also in a few of those at EPFL. So the gap in the market that we have for people who can go on and do many of these things in AI is huge, and this is only increasing with time. To touch upon that, in this particular talk, I'll be talking about I'll be addressing two types of questions. Is what can you do with AI, artificial intelligence, and what can you do for artificial intelligence? And both of them are two different aspects of the same coin. Now, what can you do with artificial intelligence? That's an easy one because the media has done an amazing job. Many of us here in this talk, you have a very good idea of what you can do with artificial intelligence. You can, look at videos of people dancing and figure out how many people are there, how they're dancing, whatnot. You can look at images of plant leaves and figure out what disease they have. You can use it to create art. You can use it to play games, not games, like lots of games. You can use it to understand satellite imagery. You can look at satellite imagery, figure out what buildings there are, how many buildings there are, so on and so forth. Or if you push it a little bit further, you can use it to also generate satellite imagery because satellite imagery is expensive to access. But the question is, how do you do many of these things? That's a question where many of you will take a step back and think. And when I ask you, what can you do for artificial intelligence? There's also like another bit of a confusion. And most of the perception is people who do artificial intelligence, they are in front of this whiteboard doing all this nerdy mathematics, whatnot. It just looks scary and overwhelming. And most people have no clue to how to get started. And I guess many of you feel the same. And you are not alone. There's a majority of people, a bunch of millions of really smart engineers who feel the same way. And I have been in academia for quite some time, and I kind of push on this idea, which I really always despised in the way we do research. I call it elitism of expertise. Only because in academia, we kind of did a few extra courses in linear algebra and probability. We say only we can do artificial intelligence, and no, you cannot. And this, you on that other end, is this really smart engineer somewhere in India or China has been building so many cool things using so much code and mathematics, yet the barrier to entry for this particular persona is huge to even think about doing anything in artificial intelligence. But across, in this talk and across what we do with AI Crowd, much of my message has been to convince a much larger number of people that we have in research right now that you can contribute a lot to artificial intelligence. And we, here when I say we, I'm kind of representing this community of elitist researchers who always are kind of, in front of whiteboards. We can learn a lot from you. I will tell you the story of Bob and tell you this context in the story of Bob. Bob is a simulated skeleton which lived in a simulated world. And this was a problem I was working on at the beginning of my PhD. And the problem was simple. With Bob, you have 18 muscles, and this is like real muscles of a real human body. And you are like a puppeteer where every 10 milliseconds, you have to send signals to all the muscles at the same time. If you send a 0, it's complete, the muscle is completely relaxed. And if it's 1, the muscle is completely contracted. But to kind of make it a little bit hard, if you actually get to control how much is it contracted. So you send a value between 0 and 1. If it's 0.5, then it's only contracted halfway through. And the problem statement we push through is, can you be a master puppeteer which can help you make Bob walk by coordinating all these muscles as well as you can? And across this problem, while we started working on this problem in the beginning, of course, it was a pretty hard problem. And then we use something called as reinforcement learning to approach this problem. Bob barely manages to take a step and it basically falls face flat. Then, oops, sorry. I have a bit of technical issues. Oops. Oh, yeah. Then you basically, I'm not sure what's happening. Then you basically train it a little bit more, work a little bit harder. Then it basically learns to take the notion of step. Then you train it a little bit more and you realize it's actually a little bit more sneaky than that. it realizes that, okay, it cannot figure out how to walk, but the goal was to kind of move as much forward as you can. So it figured out a hack that I basically take a step forward and make it do this perfect dive so that I maximize the distance I cover. But we realized there were some issues in the problem formulation. And as we started working on the problem, we figured out how it can actually move forward, except it was not working like us humans. There also, we realized we were not penalizing Bob for using as much muscles as it can. So it was not conserving energy at all. But taking into account all these things, Bob finally figured out how to walk pretty much like human. Across these millions of years of evolution, Bob finally figured out by just self-play, using by trying to optimize this one reward of how much distance it can cover, it figured out how to walk. The interesting bit is, across all these things, we managed to kind of solve this pretty hard problem where this musculoskeletal model was walking just by playing with itself in this simulated skeleton, and a puppeteer had learned how to teach a simulated skeleton how to walk. But all of this was not actually done by a single researcher. In fact, when I had pushed this problem in the community, it was me and another collaborator from Stanford. Many members in the research community was that at that point of time, this was a very hard problem. This was like the number of dimensions in the problem and how slow the simulator was, whatnot, made the problem very hard to kind of solve. So many people were very pessimistic. So we back then the project used to be called as Crowd AI. We put up this problem on this research platform that we had started at EPFL, saying anyone who wants to come and help out with this problem, you're welcome to come and work with us on this. And about 500 participants came together and made 2,000 submissions. And each of these submissions is a separate neural network, which is trying to teach how to, which has kind of somehow learned how Bob should walk based on coordinating all these muscles. And across this, we also had a bunch of really interesting observations. Many of the top participants in this large experiment were not our same small group of researchers who work on reinforcement learning, where we hang out in these handful of conferences like NeurIPS, ICML and whatnot. But many of these people were just developers who were curious that what is this funny thing in this animated simulated setup that is trying to walk, and what is this code which is trying to make it work? Can we basically learn from what these guys are doing and figure out how to make it work? And in the process, many people also gave us a lot of feedback that many people had no clue what reinforcement learning was, what deep learning was, what TensorFlow was, and they were just learning on the go. But many people were also not kind enough. They were also pretty harsh. Some people were like, yeah, this is broken, this is that, this is so on and so forth. But these negative comments were also turned out to be pretty helpful, because they helped us improve this core research platform that we were kind of working on, this problem of how to make a simulated skeleton walk. But the opinions that were coming in were on very nuanced engineering aspects of the whole problem that we would have as researchers standing in front of whiteboards completely ignored. But these guys came up with optimizations which catalyzed the progress with which we managed to solve this particular problem. And overall, a community of 550 participants from all over the world came together to solve this problem, and we loved it. And this experience itself was eye-opening, because we had no clue that so many people with no experience on a problem like this can come together to solve such a hard problem, where these guys were getting research papers out of it. And this other group of people had no clue that they could actually end up writing a research paper in a fancy journal in AI. But how did all this happen? Of course, there were some incentives involved when we started this project. It kind of picked up a little bit of steam in the media. Then NVIDIA came in, and back then they had launched NVIDIA DGX1, which was like this supercomputer in a box, like costing a few $100,000 or something. They gave it as a prize. They said, anyone who solves this problem, we'll give you a DGX1, which is a supercomputer in a box, for you to play with. And they did it, and the winning team basically got it. Another also aspect of it was the problem formulation of the way in which you approach problems like this was actually pretty simple. It's actually my area of interest, my academic area of interest, something called as reinforcement learning, where the ideas are simple. You always have a simulated world, and you have an agent. In this case, the agent is the puppeteer, and the environment is the simulated world in which Bob exists. At any point of time, the agent has to kind of send an action. Action basically means all the signals you need to send to all the muscles of Bob, and the environment basically says how much did Bob move forward, the reward, and what is the updated state of Bob. In this simplistic setup, you can actually use reinforcement learning in a particular way to kind of approach a whole variety of problems which kind of fit this paradigm. And not only that, for many researchers who are not traditional researchers, we actually spent in a disproportionate amount of time to actually aggregate all the documentation on a lot of instructions on how you can get started. For example, for a problem like this, to get started is not very difficult. At the end of it, you just need these 5 lines of code to basically get something up there. Here we just do random actions, and then Bob keeps falling forward. The question is, how do you write a controller where you given this particular state, you just choose a set of actions? And in the particular context of these competitions, we also managed to convince that, things have moved quite a lot over the last decade. And doing much of the research in artificial intelligence isn't as complicated and nerdy as it used to be back then. Now, because of the existence of many high-level frameworks, you basically are kind of acting at a much higher level than you can imagine. The whole thing, you can actually imagine it as a game of Lego, where many of these little architectures that you see are these Lego buildings that you are building, and you have a whole variety of these building blocks that you can use. Now, of course, in Lego, you have real pieces. In case of much of this research, you have actual code. And this code itself is also something which is a lot more accessible than it used to. And using just these basic ideas and some introduction to some of these basic ideas and the tools that you need to use, participants managed to train a lot of really interesting approaches which helps us solve this problem. And in the process, we also helped optimize, many nuances of the whole aspects. And these were all community contributed contributions which came in, which helped us improve the particular research project a lot more. And the thing is, this particular problem for paradigm that I mentioned to solve, Bob, is not something which is just one-off for solving this problem of teaching simulated skeletons how to walk. You can actually do a lot of things using a problem like this and the same game of Lego that I mentioned here. We actually ran a series of other competitions around it. For example, can you train an AI which goes in and plays Doom? Not Doom like one of the Doom bots, like a pretty human, where at any point of time it sees what a human would see, and it has to just decide which key presses and how to move the mouse and so on and so forth, so that it goes on and plays a deathmatch inside Doom. So there also participants started coming up with very interesting models with these bots competing in tournaments and doing these tasks where suddenly these bots were starting to become overwhelming to average human players. Then we ran something with Microsoft on Minecraft, where you had to kind of solve a series of different tasks in Minecraft, which involved collaboration and cooperation. Can you climb a wall? Can you cross a lava bridge? So on and so forth. Then we had something on adversarial vision. Again, this is where Google Brain, EPFL, many key players in the whole setup came in. And these were serious researchers who were working on this problem. And the problem was simple. Like you are given this image of a panda, and all the best AI models that we have, they say this is a panda. Can you add a little bit of noise to this image so that you cannot even perceive it, like the image, the panda on the right, but then the model is completely confused? This seems like a silly toy problem that you're working on, but in the age that we live in and across the next decade, this has huge implications. When self-driving cars are on the road, imagine the possibility of having a simple sticker on a stop sign, which suddenly confuses the AI model inside the self-driving cars to think it's not a stop sign, it's saying go full speed on this green signal. So setups like these are like problems which will affect us in deep ways, in more ways than we can imagine. And here we managed to engage a lot of people to work with us. Same on other problems, on many other problems on detecting satellite imagery, on understanding satellite imagery, so that humanitarian organizations can look at satellite imagery and figure out how refugee camps are changing over time. Or a big research project here in Switzerland. Can we look at images of food items by actual Swiss users who take photo of everything they eat and understand what is the food, what are the food items these users are eating, so that we as researchers can dare to ask high-level questions like, what is the nutritional intake of Switzerland at this point of time, which itself will inform policymakers and whatnot. But this is again a problem where many people from Switzerland started kind of contributing to this particular problem, and they themselves would sooner or later in the future be affected. And these were people who had no clue they could actually work on problems like these. And suddenly it was like opening a window to them that while they are learning, they can help us push the state of art of research on a whole variety of these problems. Another one of those was with the Swiss National Railways on, can we actually train in a simulated world? Can we basically come up with a better way where we train AI, which schedules these railway networks in dynamic simulated railway networks, so that again, whenever there's a little delay somewhere, the network self-adjusts so that the delays across the whole of Switzerland are minimized. And this is where a major Swiss company is coming in to engage hundreds and thousands of people to kind of work on this problem and help push the state of art in this research. So on and so forth. Like, we worked on more problems in Minecraft, and also this year with OpenAI on can you train a single AI which can play hundreds of games, no, actually not hundreds, it's actually 16 right now, but the goal is to kind of reach hundreds at some point, 16 different games at the same time without any custom tuning. So this is like where we can train AI which generalizes to multiple tasks. Okay, it seems like a silly task right now, but when you replace the notion of games with everyday task, then it becomes a lot more tangible to any AI assistant that we will have, any tangible AI assistant that we have at a time. So across many of these experiences, much of our push has been to kind of convince everyone that you can contribute a lot to artificial intelligence and we can learn a lot from you. And in this journey, I think we have also learned a lot just from this experience of many other people coming in and working on these problems, even if they thought they were not AI researchers, and many of them ended up getting a lot of academic footprints in terms of research papers, and many careers were made. We identified and discovered many rough gems who needed the right connections and the right support and right resources so that they can go on to do many amazing things. And with AI Crowd, we continue to push to kind of do the same, where we can identify and find and engage millions of users, developers all around the world, and help us in pushing how we do AI, so that not a small group of researchers who are isolated in this small part in one big country in the world, where they do not have all the say in how AI research takes shape, but we can enable anyone all around the world to come and help us choose the direction that we want to take for many of these problems that will affect us not far from now. But why do we want to do this? As in, again, why would I want to basically quit my PhD, do this so that we kind of engage a lot of these people? My personal goal is across by engaging hundreds and thousands of these people on hundreds and thousands of these problems, is we will be able to create an open knowledge graph of reproducible solutions across all these problems. People submit their AI code, which we will run on our own compute to solve these problems. And many of these code submissions are openly available and are available in this large open knowledge graphs, which are different problems connected to each other semantically and their associated solutions openly available. So that someday soon, where someone without enough access to resources who is trying to learn is want to basically take this problem, and or any organization, let's say humanity organization, who wants to take many of the solutions that come up from these problems and want to use it, they don't have to go out and try to find and build an AI team while struggling and competing with entities like Google and Facebook. They can come to this large open repository of open solutions and open problems, and then reuse many of them for problems that matter, and hopefully end up actually maximizing the overall impact that we can create with AI by better coordinating the community that we have. And our ambition is to be the largest open knowledge graph of such reproducible solutions. And I'm pretty sure you guys can help us get there. Thank you so much.
Mahanti, thank you so much. Wow, that was a lot. That's
sorry, I also speak fast.
No, in a positive way. Wonderful. Thank you so much for bringing that energy, bringing that passion here. You're clearly well energized for the Q&A session, so that's really great. Please join me in thanking Mahanti here on the chat. Just let's show a little appreciation to him as well. Do you want to stop sharing, Mahanti, so we can get back to our grid view? Brilliant. Thank you so much. You've heard me speak plenty tonight. I've no interest in speaking anymore. I really want to see some people on mic now ask some questions. Christoph's still here. Richard's still here. Obviously, Mahanti's still here. I'm just clicking through to see who else we've got from earlier. We can find that out. Niraj, are you there? Do you want to unmic? Ask a question?
Yeah. Hi. Yeah. So it was very interesting presentation, Mohanty. Just want to check, while you have given a lot of use cases, basically the masses don't really, still understand what AI is all about, and they still think of it as a black box. And if they are not comfortable in knowing how the decision was made, they are eventually not comfortable with the AI. So how this situation can be handled?
That's a good question. Again, that's a question I think about a lot. Because if we want to enable many people to use it, first they need to be comfortable with it. So it is true that many people think of AI as a black box, but also not true at the same time, because many people think AI as a black box which is not accessible. So imagine a CTO of a really smart CTO of a traditional company who has no experience in AI. this person, when they have to think, okay, we have to build a product around AI, let's say understanding satellite imagery. Right now, they don't feel that this is something that can be probably done in-house, or you can take the first steps. Right now, they're like, okay, we need to kind of find these AI wizards somewhere who can come in and do it for us. So the first step there is to actually acknowledge that it's okay if these are black boxes. But can we enable you to use these black boxes, even if you do not know how it works internally? You just know that this is this black box, like this black function where you pass in this image and it gives you annotations of where the buildings are and so on and so forth. So the first step would be to kind of make a lot of people comfortable in using these black boxes. And at the same time, we have to also convince a much larger team of engineers that it's okay. It's okay to take a step back and open these black boxes and tinker around and see what happens. You cannot break anything, and it's a safe space in here. So looking at both these things at the same time, at the same different levels, will basically, you know, somehow help us push, make AI less of a black box and more of like a everyday tool that everyone uses.
Thank you so much. Alex, do you want to ask your question to Richard?
Yes, I'm here.
Sorry, find the mute button. Yeah, so very interesting talk, and obviously very large amounts of data. What I was interested in, from your perspective, Richard, and possibly from other people, did you find anything analogous to Mohanty's bouncing skeleton? Anything that you might not have expected by doing large data analysis in an intelligent way, in inverted commas? Did you find anything that was really not something that humans would have expected to be there?
Well, we did see a few things. For instance, when the schools were closed down, in Spain, many families have second houses, yeah, because of their families, their grandparents, etc. So if the school closes down in the weekends, people move to their second house. Yeah? So there was a lot of hype and pictures on the journal, on the news in the evening, about people from Madrid, yeah, who fled all to their beach houses, and the risk was that it was overcrowded, that they were overcrowding the health services there, and they would collapse the intensive care units. And there was even some kind of hate against people who moved to the second houses. And when we looked in the data for those specific days and between specific areas, we didn't see any spike in those things. And that means, so we have anonymized aggregated data. So we don't see everything because small groups are filtered out. Everything below 15 or 20, you don't see. But so if they found this, then it was more an anecdotal thing than rather a common thing everywhere. And actually, we got a lot of requests from the local governments of those areas, but please tell us, we are afraid, we are afraid that our hospitals are being overbooked, but it didn't actually happen.
Yeah, that's really interesting, because we had similar suspicions in the UK, but as far as I'm aware, we haven't seen any data one way or the other, whether people really did all go to Wales or Cornwall or the Lake District, or whether it was just rumor.
Yeah, so we have now in Spain, we have some new outbreaks, and they are all popularly associated to young people who have partying in the night, in the evening. But of course, those are relatively small groups which we cannot see in our data. But probably there are other methods to find out whether this is really true or not.
Thanks, Alex. Thanks, Richard. Alex, anything else?
No, I was just saying thank you.
Lovely. Thank you so much. Jack Norton, are you there? Do you want to ask a question?
Oh, yes. Good afternoon. Yes, apologies. It was to Shraddha. It was I apologize. I've just joined in from the breakout session, so I may have missed something that I'm not getting. I just jumped in where you were showing a single AI that could play multiple games at the same time. And I kind of get why it would be really cool to have a single AI which can play any game you give it. But I don't understand why it's interesting that it could play them at the same time. So I'm assuming these games aren't related to one another, because what happens in one game doesn't affect what happens in another. So what's the benefit of having one single AI that's playing them all at the same time over having just a different AI playing every game?
No, that's a very interesting question, and also has roots in like the way we theoretically see AI. But to kind of get a real world parallel in there, what we actually want in context of AI, especially when we in the future want to talk about general artificial intelligence, whatnot, is this one vessel which can learn any task. Now, imagine you have a bunch of tasks at home. Let's say you have to kind of cook some food, like cook a pizza. Another one is to wash some laundry. And another one is basically, I don't know, clean the house. For all these three tasks, we are kind of in context of artificial general intelligence. As a human, you always know that you can take the same human, teach him how to do this task, and the human will always figure out how to kind of do this task well. It depends on how well you teach him, or how motivated this person human is. He will eventually end up doing all these tasks over and over again. So this is just one empty skeleton which has the ability to learn to do a whole lot of things, even if these things are completely different. But many of these things might have a bunch of things which are common. For example, to be able to cook, to be able to clean, and to be able to do the laundry, you need mobility of your own body. You need to know how to navigate, how to plan, and whatnot. So while doing one task, we are also partially solving some high-level task of the other task. So if we can demonstrate that the same empty skeleton, empty black box template can actually go in and solve any series of tasks that you can give it, then you are demonstrating that this learning strategy that you have can actually scale up to a whole variety of real world things, which will actually, the thing will be faced when we actually deploy it ever out in the society. Does that answer your question?
Yeah, no, that does that. Thank you very much. So like if you had an AI, really simple example, if you had it try and learn to play Super Mario and Super Mario World at the same time, it might actually learn to play those games quicker than if it was just playing a single one in isolation, because they're related. Yeah, that's a cool idea. I like that. Thank you for explaining that.
And there's another catch there too, because traditionally when you talked about AI, like about go back 15 years from now and others, where many of the bots that you would see for many of these games, Counter-Strike, AI and others, were a bunch of rules. So even right now, when you're playing many of these big games, the bots and the AI that's actually sold in there or pitched in there are just thousands and thousands of handcrafted rules. It takes months and years to build those rules. And in a setup like this, when you are kind of coming up with this, spending months to kind of come up with this set of rules to play, say, Super Mario, and suddenly you change the game, then do you have to sit down and invest to kind of write the set of rules for another game, let's say Angry Bird or whatnot? But if we actually give it a whole variety of games, and in some of the games, the actual, the programmer, the engineer who's designing the AI never even gets to see the actual games the AI will play, then it becomes a lot more interesting. Then the engineer, AI researcher will have to push for how to kind of build these templates which can learn from experience and truly learn without giving these hacks and shortcuts that we give in context of rules.
Yeah, like how when a human plays a game, they obviously, I know how to play a generic platform game because I've played Mario before. Yeah, I like that. Anyway, thank you. I'll let other people speak.
Thanks, Jack. Thanks, Mohanty. Paul, are you there? Do you want to ask your question?
Yes, I mean, it's a question for any of the panel, but maybe Christoph might want to start. But it's really something I've been fascinated for a while, that when you take AI as a starting point, clearly a lot of innovators are starting with the point of the human form, the humanoid form, and they anthropomorphize. So they create stories around, we can make the house faster, we can play a game better. And the starting point is the human. Others have particularly imagined the starting point of AI of being an alien form. It doesn't need to follow the dumb behavior and the kind of limited form of the human being. And then we end up with kind of alien forms of AI that can parallel process with 15 brains and 25 arms and so on. Do you think looking forward that I suppose it's a leading question really, but if our starting point is to anthropomorphize, the danger is that we just get AI to replicate what is already a problematic set of processes that the human being is kind of essentially weak?
Christoph, can you take that one?
Yeah, I mean, there are some people who say it was a mistake right from the start to see AI as something that would try to mimic a human intelligence, and we would rather be better off now changing our ideas fundamentally and look for some form of intelligence, but not something that tries to recreate human intelligence. So that I agree with that. I mean, on the other hand, at the moment, I think I do not see this as a very problematic question. I mean, we have so many problems with making AI not too dumb, actually, and rather. So I don't see this as a relevant problem now, but I agree that we should not all the time in the future try to mimic human intelligence. Yeah.
Thank you.
I'll dive in with a quick one myself. Richard Benjamin's talking about predicting epidemics. We'd need a lot more collaboration, wouldn't we, on data? I mean, we had the data about COVID-19, but it took us months to trust it, act on it, verify it as not being fake news. Is it collaboration or something different that would create a faster, different outcome next time?
Well, I think first of all, it is a matter of digital transformation. Yeah, so this is governments who have to act on data, and in general, governments are lagging behind the commercial world. Yeah? So many large companies have gone through a digital transformation. They all have AI or big data departments, but it's only starting at the government level. So it's not institutionalized that they can work with this from the beginning. Yeah, they had a very steep learning curve, and they had to get a lot of external advice to make it happen. Yeah? So that's one of the problems why it took so long. And then as the same, I mean, the number of cases in the country, I mean, it is all aggregated. Yeah, depends of course on the country how much they are digitized. But for instance, in Spain, it goes from the hospitals to the cities, to the provinces, to the regions, and to the central government, and it's all manual. Yeah, so that's why after the weekend, so on Monday the numbers are always low, and then on Tuesday and Wednesday they're a bit higher because they have to catch up from the weekend. Yeah? And that reflects. So it's basically a matter of having a digital mindset, the digital capacities to deal with so much data and to act on it. It has to happen, but it will take some time.
Thank you. Thank you. There's an open forum here. We've got a few more minutes for questions. Who else would like to contribute a question or a statement or an idea? Manji, why don't you tell us more? So we talked about simultaneously playing this idea of two different versions of Mario at the same time. Does that come into the question of AI being more diverse and AI's learning in different environments, different cultures, different situations?
Yeah, I think it's more about being AI being more diverse and also dynamic, where it can go in and adapt. The whole notion of something which can go in and adapt to a particular task is very important, because the whole notion of cooking is very different actually, because you can teach an AI how, let's say we have given the task of teaching an AI how to cook. So someone, let's say, gives it a set of instructions. The old school way would be, the classic systems way would be you give them a set of instructions. You have this robotic arm, you have to kind of, let's say, make pizza, you give it the whole recipe. But then at the same time, let's say this AI is being deployed in India, and now you have to cook a curry. Then the whole thing is completely different. The question is, can it adapt to a whole set of tasks and build upon the knowledge it had in a previous one, or it can independently learn both these tasks with equal efficiency? And there might be some tasks where it finds it struggles to learn about, some tasks it does not learn, but across a whole majority of tasks, it still has the ability to kind of learn this task without any expert hand-coded rules. That way, whenever you are presented with a new task in your setup, be it a humanitarian setup or a corporate setup, wherever you think AI can be used, you don't have to hire a large team who has to sit down and write rules. You just define the task, throw a lot of compute, come back after a few days or a week or a month, and this thing has learned how to do that task well.
Can I make one comment on this? Because I think it's important. I mean, this is all a data-driven AI, yeah, based on machine learning, learning from a lot of examples. But it's important to understand that those systems have no clue what they're doing. They don't know about cooking. They don't know about curry. They don't know about the ingredients. Yeah? They just have seen a lot of things and they abstract and they learn patterns. Yeah? And that is the current state of AI. So it's very good at very specific tasks. Of course, you can try to extend it to with transfer learning to other tasks, but they cannot reason. They have no common sense. Yeah, they have no notion of what they're doing. So we should be careful in not thinking that we can create today something that is closely to human intelligence. Yeah, even if that might not even be the goal, but I mean, we're still very far from that. And that's why it's also that machines, like especially deep learning machines, have a hard time in explaining what they do. Yeah. Because they don't do it the way people do. Yeah, so they can explain what they do, but we simply don't understand.
Well, that's exactly why we need to kind of challenge the research community with tough tasks like this, right? Give me one model which can learn how to kind of play in different games where some of them you haven't learned, but also this notion of reasoning, comprehension, common sense, and many other things. And the way we perceive it in the research community, it's also being challenged by much of the progress that has been done in say language modeling per se. Because until now, one of the running hypothesis right now is these models were very specific to a bunch of tasks and were not generalizing across a whole lot of tasks, because these models were too small given the amount of compute we had, the size and others. But recent results from language modeling tasks like GPT-3 and others, where you see this one large model is suddenly kind of solving a bunch of other tasks without any extra supervision or training, right? Where it has learned how to basically look at large piles of text and answer meaningfully some text, make coherent text, and the whole things, where the whole goal was to train a model which basically figures out what the next word would be, or how to fill in the blanks for a lot of sentences, but kind of have a human and make this human do billions and billions of fill in the blanks examples. And then suddenly this human has kind of learned this notion of a semantic relationship between concepts, how to do question answering, and many other zero-shot learning tasks. So we are kind of still getting there, but of course not to a point where a single AI can actually learn how to cook different things and other things. Those are still in science fiction. But in terms of theoretical results, these results from language modeling do show that we are getting much and much closer to this idea that the same model can solve many tasks.
The question is whether GPT-3 understands what it says.
The question could also be a pushback. Do we understand? How do we answer these things? Because at the end of it, it's a bunch of these neurons firing each other.
Rich, I've just got to say that whilst you were dismissing AI, you were also calling it they. I just want to pull you up on that. Is that an answer for formalization? I don't know if Joaquin is still there. I just wondered, and actually Christoph, do pick this one up if he's not. In the UK, we call our doctors GPs, general practitioners. Obviously, we note that they have this wide understanding across many different ailments and illnesses and health. Sounded like the conversation we're having there, really big opportunities in health where it can learn from many different domains rather than maybe what we see, which at the moment is quite narrow AI in health, trying to diagnose one problem in isolation. Joaquin, have you got any thoughts on that?
Yeah, actually, I think that's all the capabilities of integrative medicine. I think that this is one of the most active areas of research. I think that's right now the area where you get one particular acquisition on radiologists, and then you go to a lab to get a blood test, and they don't share this kind of information because they belong to different services in a hospital. I think that AI has the capability to find ways to integrate these different parts of information. I think that's right now there is an effort, I have seen this in many different hospitals, of people gathering together and trying to get combine a task force, especially with the COVID-19, just to combine all these different information that's right now that has been kind of scattered around different services. So I think that this is going to be one of the most successful attacks on how to approach COVID-19 from the medical perspective, collecting and getting information from many different sources. I know different big companies such as Microsoft are attempting that, and many others. So I think that's the outcomes, and this is something that it's ongoing because this is all really recent. Is gonna be quite astonishing. That's how, if you get all this information from that has been scattered so far, has a really powerful predictive solution.
Thanks, Joaquin. Christoph, do you want to comment on that?
I don't think so.
We're very inclusive, and I'm just conscious that we, maybe didn't get so much time with you on the Q&A, so that's fine. Richard, do you want to comment on that?
Yes, I think with the current state of AI, which is basically data-driven, database AI, we can still apply it to so many things that it hasn't been applied to. So I think maybe we touched only 10% of all the applications. So the potential impact of this technology that now is mature and it's getting even better and better, as we saw with this language model GPT-3. If you haven't seen it, it's impressive if you see what it can produce. It writes even tweets. It is true that you have to discard 40% of the output or more, but sometimes what it is amazing. And if you talk about healthcare, there is so much data that still can be used with the same technology and create enormous amount of wealth and opportunities for everybody. But this is not the end of AI. It's just the first important step. As I said, look at the child, a baby who gets born, knows nothing. In 18 months, it knows a lot of things. It has common sense, it has object permanence, it has causality, and AI doesn't have that yet. Why is that? It's a philosophical question, but we share a common reality. So even though we don't understand what's happening in our world, in our head, by looking at other people who do the same as us, we interpret that we have this common reality. Now, if it's only a machine, then it has a different reality. So maybe if you have different machines talking together, they might have a common reality and understand each other, but we will not understand anything, a clue about it. But then again, you have to go beyond just learning from data. You need to have common sense. You need to be able to reason, to infer things that are not there. We can infer things that are not there. We can do hundreds of things reasonably well. Maybe we can do 2 things very well. But an AI today does 1 thing very well, and that's it.
And maybe just I would like to follow up very briefly on that, because that again raises the question of guidelines for AI and ethical guidelines, as well as at some point we will certainly see regulation on AI. But for the moment, I think ethical guidelines is the most important way to go. And here I would like to follow up on the question also that was raised in the chat recently. I think this is something that many companies are recognizing, and not just the big companies, but also small companies, also startups that come to us, for example, as an institute and ask us what should we do about the ethical side of machine learning, of AI. And how could we approach this? And I think this is something we need to work more on, and in a collaboration with academia, industry, and civil society. I think this is a very important step to go. And for example, here at IAI, we are looking at how to structure this, actually, how to structure this kind of collaboration, and to put those necessary non-technical skills into development teams, for example, into the development process, because there's a demand for that. And I think this would be a great step to take, and how exactly to do that is something we would like to find out together with others.
Christoph, thank you. Thank you for taking us home. It is 6:59 here in the UK with the sun starting to set. We've certainly had the longest day of the year. That's well gone now, and the days are already getting shorter. Huge thank you to Joaquin, to Ali, to Richard, Christoph, Mohanty, and of course, Melissa, who was with us earlier on. But most of all to you, to making this what it is. Thank you for those of us that have contributed, and those that have joined, and everybody who's a part of this community. I will put up the next event here in the chat for August the 20th. So do shout your appreciation if you want in the chat for our speakers tonight from across the world. And thank you again from me to everybody. Do just jump into that August now, book nice and early, and then we can start seeing the numbers. So if you want to unmute and say anything, we're closing in about 30 seconds. Thanks again.
Thanks for a wonderful session. Bye.
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 We need more kids in this, definitely.
They're the future. Gents, thanks so much for your contributions. I see Richard, Christoph still there. Incredible. Thank you.
Thank you so much. It was a great session.
Good. Thank you. Thank you. Thank you. Henry, your contributions. Adrian, thank you. Vesna, thanks for joining us. Nima, thank you. Jazel, you're the best. I wonder if Luke's still there. Jerry's still there. Thank you. Niraj, thanks for your contributions. James, thanks for moderating. Tim, thanks for being amazing. Karen, thank you too. Rodrigo, Thomas, JJ, thank you. Diego, Harin's here. Great to see you. Abel, Sylvia. Bridget's arrived. Joaquin, thank you so much.